In this video, we're going to look at the beginnings of conditional probability. So if we imagine two events, events A and event B, conditional probability is where you've got to work out the probability of an event A occurring if it is known what the probability of the event B has, because it's already occurred. This is usually written with the notation the probability of A given that we already know B. So I'm going to consider a Venn diagram. I'm just going to draw up a Venn diagram that we've used before with apples and bananas. I'll let A represent apples and B represent bananas. So here's the Venn diagram. So what we've got to do is find that if a student was selected at random, what's the probability that the student liked bananas? And then what's the probability that a student likes bananas given the fact they like apples? So what we have here is a survey of 33 students. Just double check, 12 and 7 is the 19, plus the 10, 29, plus the 4, 33. So we have 33 students within our universal set. So the probability that a student picked at random likes bananas is this circle here, which is 17, out of the total 33. Now, when we're looking at whether we want the probability that a student likes bananas, given the fact they like apples, we're only interested in the apples. So this circle that I'm highlighting just contains all those students that already like apples. So the probability that a student likes bananas is 7 because that's within the intersection of the bananas, and that's out of a total 19 students altogether. So what we're looking at is only those students, sorry, I was going to write 7 out of 19. There we go, which is correct that. So 7 out of the 19, because we're only interested in those students that had apples. It's not out of the whole university set anymore because we were given a condition. Now there's another way that we could look at this, and this leads us to give us a formula for conditional probability. And that is if we work out the probability of those students that like both apples and bananas, so the probability of liking apples and bananas is 7 out of the 33. And if we then look at the probability that the student just likes apples, well, that's 19 out of 33. If we then take this and divide it by that, we end up getting the same answer as here. I'm going to show you that in a second, which is 7 over 33 divided by 19 over 33. Obviously, using the multiplication rule, we've then switched that. So that's 7 over the 33 multiplied by 33 over the 19. Now, as you can see here, these two will cancel just to leave us with 7 over 19. What you'll notice is that this is actually the formula given for conditional probability. I like to use Venn diagrams as a visual to explain why this works. And we can see we've got the same number, 7 over 19. So I'm going to do a second example here where I need to draw a Venn diagram. So I've obviously written this in shorthand, but it's basically in a class of 12 students, in a class, 12 students study Chinese, 20 study French, and then 8 study both. So I'm just going to set that up in a Venn diagram. Then we're going to work out, well, what's the probability that a student studies French given the fact they already study Chinese? And then we're going to do it the other way around. What's the probability that a student studies Chinese given the fact they already study French? And what we're going to do is look to see what the differences are between these two relationships. Alright, so let's have a look. So we're interested in students that study French given that they study Chinese. So let's just look at the given condition here, which is just studying Chinese here. That's given. So we have a total of 12 students there. So our probability will only be out of this circle here, 12. What's the probability they study French? 8 out of 12, which can be cancelled down to 2/3. Let's have a look at this. What's the probability that a student studies Chinese given the fact they study French? So we're only interested in this circle here for French. In this circle, there are only 20 students, so our probability will be out of 20. The probability they study Chinese is now 8 out of 20, which cancels down to 2/5. As we can see, these two are not the same, so you really do need to be careful which one is the given condition, because that will tell you what your probability will be out of.